Hi viewers, this is ISIFE EDUBLOG. My name is Mr. P, and in this video it is part 2 of 2024 Waec practical alternative A interpretation to students and teachers. In this part 2 video, it is going to be identification of ions. Okay, this instruction is also a guide to students and as well as teachers. Okay. This is a major area where students shows their weakness. In this video, I'm going to be unraveling around so many weaknesses and errors that students most often commit when they are carrying out a titration. Okay, now you are given two salts, two soluble salts. Sodium triisocarbonate 4 and lead 2 triisonitrate 5. The two salts are soluble based on the principle that all sodium salts are soluble in water, or based on the principle that all triisocarbonate 4 salts are soluble in water except those of sodium, potassium, and maybe ammonium, or except those of group 1 and that of ammonium carbonate are all soluble, the rest are insoluble. All triisonitrate 5 salts are also soluble in water with no exception. So the two salts are very, very soluble. This is where the student also going to make mistake. Okay. Now, you are, as a matter of fact, are going to be referring to these two mixtures of inorganic salts as sample C. Okay, so you are going to see it as sample C. Since in this video we are not doing the real experiment, we are just doing the analysis, the real in-depth analysis to our viewers, and most especially to our SSCE students. So you share the video, okay, so you can cut across students that are writing this work. Okay, now, in this video we are going to explain how these ions are identified in qualitative work or tests. Now these salts are mixed together in the same ratio. Maybe 1 spatula full of this, 1 spatula full of this. The two are mixed together, and then we have to identify the ions. Okay, so in this aspect of this experiment, extra care should be taken because credit is being awarded for every instruction that is given to the candidates, and then that those instructions are obeyed to the letter. Credit should be awarded. Okay, they say the examiner is stated clearly in the question paper. So we should see ways to interpret this, and all of this identification should be presented in the table under the subheading tests, observation, and inference. But before we set up the table and then do the real analysis, I'd like to explain to you the behavior of each of every of ions that are going to be playing out in these two inorganic salts. Now, remember that in salt analysis there is what we call preliminary tests. Yes, preliminary investigation is just an investigation that you as a student, and maybe when you go into the lab and then you are faced with the experiment, and then it's this aspect of the experiment in chemistry whereby you are given salts, and the first thing you should do is to be able to look at the salts and then predict what you think. Because no candidate or student is allowed to even have an idea that this is the result. Because you see the result is like you're actually going there to just maybe not do the practical, you just concentrate on writing what you think is the answer. Okay, but during those years, that is how practicals are done. You're going to see it as C. Then you have to carry out a practical work on that C. And then at the cost of carrying out practical work on that C, be able to now predict that this C does look like it's actually these two things. But being that we are seeing that this is what C is, this C is equal to this two mixture of the two inorganic salt. So the preliminary, the first investigation that you should be able to make is to look at the color of the salts. Color of the salts. Being that there is no, this isotony is not a transitional metal salt as well as lead. So you should expect that the color of these two salts is going to be white. White describe that there is absence of transitional metal salts, so the salt are not colored. So you should be able to know that you now rule out the possibility that there is no copper ion in it, there is no ion 2, there is no ion 3, there is no chromium, there is no manganese. And is what you should be suspecting that this salt could possibly be a salt of group 1, group 2, group 3, or aluminium, or even lead. That will now narrow your suspicion to those areas. So all those transitional metal compounds, you should know that they are not present. So that is preliminary investigation. Then you also have, we're going to have an idea of solubility rules of salt. Salt that are soluble in water, or salt that are not soluble in water. Those that are sparingly soluble in water. But in this case, these two salts are soluble salt. Okay. They were actually going to look at the real analysis of this salt. Most likely, when you see a salt like this, the first thing examiner would be, the mind of the examiner would be to, okay, maybe some of the source sample are taken. Some of the source sample will be asked to add some sample of C into a boiling tube or test tube or beaker. So I'm taking the small sample of the salt. I use small sample because too much sample will spoil results. This is the amount of C I want to use. This is the amount of C I'm using. Okay, this C implies can signify that it's NO2CO3 and then PB NO3 bracket 2. Both are soluble salts. Okay, now you will see that you will be asked to add few cm of distilled water, 10 cm of distilled water. 10 cm of distilled water should be somewhere around here. Okay, when you add 10 cm, it does look like some of the salts sample here. So when that starts to dissolve. So this is, when this is dissolving, some of the sample is reducing. Okay, so this is the amount that was able to dissolve. Okay, so this is the extent of that dissolution. So it does look like something is going to be fishing this dissolution. So maybe this part is red and going to be remains of C that does not dissolve. So let me see. This part is a part that dissolves. This part is a part that dissolves. This part is a part that is undissolved. So, what does it tell you? We're given that two salts are soluble. Now let me show you something. At the point of adding water, you have made this aqueous. This is undissolved. Let's use a different color here so it will make more sense. Okay, undissolved. Okay, now, so at the point of having this aqueous, so this goes into sodium ionization, okay, of course, and this will plus carbonates. And the point of doing so, this also gives us what? Lead 2 ion plus 2 of NO3 minus. This is what we have. So at the point of adding water, this happens. If this happens, that means this will go with this, this will go with this. Okay, so this going with this give NaNO3. Still on the principle that all nitrous salts are soluble in water, so this is soluble. So it is a part that dissolves soluble, and therefore it is one that dissolves easily. Okay? When this comes out with this, it will assume PbCO3. Okay, based on principle of carbonic salt, all triazole carbonate 4 salt are insoluble in water except those levels I mentioned. So that practically means that this layer here is what? Insoluble. So therefore, it is the part that did not dissolve. So undissolved here. So that means this undissolved is actually PbCO3. So something we started this week is now turning out this week. So we have used S, meaning that it is solid. It tries to separate this separation. So in this part, okay, this part that is undissolved, so I'm going to be using kind of this to see it as S. So this part that dissolve is no longer this what N or so okay, maybe I will choose NaO3. So technically speaking here, so this should be between Na plus NaO3 minus. But at this level, I think there are only any needed for chemical tests of ion for O-level students. So the only ion we're going to be testing is this one. I'll use this color here. This is where we're testing. We identify this. We can't identify this at this level. So actually this is what is here. So what we need to do as far as practical work is concerned is to separate, to have this out from this mixture. So that means we have to arrange another clean test tube or boiling tube. Clean test tube, okay, let's say boiling tube is much bigger. Okay? With our funnel placed in here. This is funnel. Okay? Clean funnel, maybe our filter paper. This is my filter paper. Filter paper. Okay? This is the funnel, this is the filter paper. And then I try to pour in all of this here. Okay, as I'm pouring this, these parts here will remain on this part of the paper. They won't be allowed to pass in. So you are seeing these parts going in gradually, and they'll be able to form this as this is draining. So this is how we'll be able to separate. So that passes through filter paper becomes the filtrate. And by extension, the filtrate is NaO3. So this is a portion of the filtrates we're going to identify. This is what we're going to identify. We're going to identify in what we call brown ring tests. So that is what we're going to do with the filtrates. Okay, then, so the filtrate is this. So the residue now, which is somewhere here, the residue is, this is my residue, and by extension, the residue is PbCO3, which is still in solid form while this is in aqueous form. So it does look like for the residue, we are testing both legs 2 ion and CO3 2 minus. So these are the things we are going to test as far as this is concerned. This, and then this in this direction. Okay. So that is on it. So we are trying to see how to put this thing up to look as if it's done real. So maybe teachers of chemistry should also look at this to find ways to also put their students through. Also, students also, this also video is also going to be very useful to students writing this exam. Okay, so we see. And in this video, you don't even need to carry out experiments. It's already know that this atom is going to behave here, and this is going to behave like this. So in this case of this, so student of chemistry should know that if a feature contains a nutrient, that means definitely you're going to carry out a brown ring test. Now, basically, I think for me, why this is still dreaming, okay, we're going to carry out work first on the filtrates. Like I said, the only test we're going to work on the filtrate is that of NO3. So to identify NO3 in a Browering experiment, the reagent for Browering experiments is conc H2SO4. Very careful when you're handling it in the lab. And then freshly prepared, that morning we use freshly prepared iron 2 tetra octosulfuric 6. So these are the two experiments for testing it. So you're gonna see, so the filtrate add conc of this followed by this. That means we should bear in mind that this is for brown ring. The brown ring is going to be formed at the junction of the acid and the freshly prepared iron 2 sulfates. So we're going to say it. So you have to infer what is present and what you think that is not present. So that is it. So I'll actually start with the filtrates. So you look at the board and see what we've been able to do so far on the source sample. Basically, after this explanation and identification, I'm going to put it on the table. So what I want to explain all of the characters, all of the behavior of these items before we can now summarily put it in a table under the heading text, observation, and inference. So you pause the video and just look what we've done before. I don't want to take rush in this video. So the next is now to start off with the Browering test and what is the purpose of Browering test, and as well why do we freshly need to prepare this during the Browering formation. Now this will be prepared the very moment the exam is going on. When they are sharing questions paper, the teacher should be able to prepare this. It doesn't take time to prepare it because IU2 is an unstable compound. Okay, I said the key reason why IU2 will be freshly prepared before it is used in iron ring and Browering test. The simple answer is that the compound or the solid is unstable. Why is it unstable? Because it can easily oxidize towards iron 3. And that's definitely going to be used in that state for Browering test. Browering test is a test that extra care should be taken to ensure that no form of interference, because the brown color will appear and still will not be able to see it because of the carelessness in most of the states. So it's a very, very, very extra care should be taken to ensure that the brown information is formed when it's read carefully. So the teachers are very, very good at this to make sure that they will be able to carry out this effectively to now see the Browering test. In this video, we're going to explain the chemistry of Browering. Like I said earlier, why this is prepared freshly is because it is what? Unstable. Okay. Now, the Browering, still on the filtrates, the Browering is, first of all, we've already done the reagent for it. So we have NO3 is in that filtrate, that is the main active. So sodium is still there, but like I told you, there is no identification for that in this video, in this exam. Moving on. So this, we are adding on H2SO4. Okay, H2SO4 in most aspects is seen as the king of acid. Why? It's because H2SO4, just like if I have NaCl salt, this is going in NO3, and this goes with H2SO4. H2SO4 can precipitate HCl from the salt. It's the one composition. Okay, and it can also precipitate which acid here? HNO3 plus HSO4 minus. Okay, that is the first thing in acid in Browering test. This is oxidizing acid. Okay, now let's see what happened now. Okay, now, so this is a triacetyl acid. So H NO3 being an oxidizing acid is going to reduce. This is +5 plus freshly prepared iron 2 sulfates. An addition reaction is going to happen here. So we have a FeSO4, okay, a mixture of NO. Okay, N here is now close to is an oxidizing acid. So this is actually what brings out the brown ring formation. So that is the compound responsible for brown ring formation. So the one is not exactly how to answer this, but you should also be able to know the chemistry of what happened in brown ring formation. So this is the brown ring, is the compound that forms that brown ring at the junction of the two solutions, that is the acid and then this. So sometimes I still suspect maybe in question number 3, you may be asked to draw what happened with this reaction, so that in brown ring formation you always place your boiling tube in the slanting position. Okay, and this is your filtrates. Your filtrates, okay, from the dissolution of the two salts. So by dissolving the two salts, this comes with this comes with this. So this is what makes salt not dissolve in that water. So this is the filtrate now. The filtrate, like I told you, is could be any, but any is not is split on in this case. So it's going to be it's not doing anything. What is identified here? So here we have NO3 minus. So even all the acid is carefully, the acid just goes in slanting position. And then meet up with this one. Okay? And then precipitate its toe NO3. So what is this? Is conc H2SO4. Okay. The brown ring is formed immediately when, or sometimes this may go before this. The brown ring is formed at the junction. You see it's as ring. There's a chemistry with a ring. Chemistry with a ring. You see it's like this. You see it like this. Okay? And then you will now see the freshly prepared cake out to separate like this. So this is how we're going to see it. Sometimes the brown ring also may also affect some parts of the test tube like this. So this is the brown ring formation. Brown ring formation. Okay, brown ring formation, which I did say that is FeSO4 addition with this, because this is an oxidizing acid, so it has reduced here. So what we have at this point, this is our freshly prepared iron 2 sulfate. So this is the level of what we are going to see if this experiment is maybe performed. This is what is expected to see. So that's we draw the diagram of the brown ring test. Just study your test, your body to be in a vertical position, and then draw an line of what we are seeing. We may be expecting this kind of question to come out maybe number 3, maybe some part of number 2, but this is practically part of this. So this is what it is in that aspect of the filtrates. Now let's go to the residue. So on the residue, you are working with, remember what we then, you can just take the video back. So that our residue is PbCO3. Okay, since this leg is undissolved in water, so we're going to look for acid that are probably going to dissolve it. So there are 3 mineral acid. Okay, there are 3 mineral acid. We have HCl, we have H2SO4, then we have HNO3. One of the acids will actually dissolve it. Okay, if you take lead on this, notes, if you take lead like this, maybe Pb, okay, CO3, and then Let this way. Let 2 ion CO3 to minus. Okay. If lead goes with this acid, lead will not dissolve because of formation of what lead to chloride. Okay, this is practically soluble. All based on the principle of all chloride are soluble except those of lead, mercury 1, and maybe silver. So this is not. So this is insoluble. Insoluble. So this acid is not dissolving it. So you cannot use this to dissolve it. So in another development, you can also run this Pb plus H2SO4. PbSO4 is also insoluble. So this acid can also dissolve lead. Could you see that the likely dissolve lead is this? Wow! This is the principle of nitrous. All nitrous are soluble. So we have Pb2 plus HNO3. So we have here PbN3 brackets 2. This is soluble. This is insoluble. So at that point, this lead carbonate will dissolve. Just like we want this thing on this. So just like this acid is acting to dissolve lead, this acid is also acting to what? To release carbon dioxide from this. Maybe as this reaction is going on, the same acid is also dealing with this in that cation. So this plus HN3. 2H will be 1 here. We have H2. What remains of this is CO2. What's now remains 2N3 minus. So this is going away as gas, which at that point, you can have the gas immediately by passing it over a lime water. What means carbon dioxide on lime water? Lime water is calcium oxide. Calcium oxide, whose solution is colorless. As soon as the gas is passed over this, to confirm that the gas is CO2, the lime water droplets remain color. That confirm the gas. Two things happen when HN3 is added to this. Two things happen. One, it dissolves, and then there is evolution of carbon dioxide. There is evolution of colorless odorless gas, which does turn lime water to milky and all of that. So this is what I think would be the first test that should be carried out on the residue, which is this. Upon doing that, the balanced chemical equation for that reaction, the complete balanced equation for the reaction should be residue, which is PbCO3. This is from the residue plus HN plus the gas that can dissolve it. So what we have here is changing this goes with this. We have PbNO3, 2 soluble. What else? 2H1O here. We have H2. What is remaining here is what? CO2. This one is not changed. This one is gone. In fact, it forms lime water in the okay. So what we technically have at this point is this. Because we are going back to the salt again. It's the salt. But this time you cannot test this solution from this residue again. So what we have is this. So you will act to divide this particular experiment, this products you obtain here into 3 portions. Okay? Let's say this is going to be first portion, second portion, third portion. Okay, now if first portion, everything should be centered on lead. You don't do this again because this has taken care of in primary information. So here we have this now. The first portion, you have lead plus sodium hydroxide. Sodium hydroxide. Okay, let me have the combination. You can use the non-ionic form of sodium hydroxide. Okay, this sodium is just a sprinkle here. So this is sodium hydroxide. So we have the PbOH bracket. It is insoluble. So it's going to come out as a precipitate. What is the color? Waec. It's not the color. Is white and the nature. White is chalky in nature. Chalky precipitates. Okay. This is what is found in drops. Based that this lead is amphotherapy, it will dissolve in alkali, in excess alkali. So in excess, the precipitate dissolves. The precipitate will disappear automatically, disappears. But there are two other cations that also show this kind of reaction. Calcium ion will do so with this to still give you the same precipitating drop, but will not do so in excess. But in drop, you should suspect this. And lead as well. And also, you may also by extension suspect aluminum. At least theory of this should be in line as far as this is produced in drops. Okay, now, I wouldn't want to put zinc in the picture. Why? Because since it's chalky, zinc is like gel. So zinc should not be there. But I'm going to allow aluminum in the with traces of aluminum in the chalkiness. We're keeping aluminum in this case, so these are three of them that we. But the moment you add in excess and the precipitate dissolves or the precipitate is soluble in excess, that means this, like this, it's oxide or hydroxide. I also have to tell you they are so going to dissolve. So at this point, since this is basic, a basic oxide cannot dissolve in base. So that is the point where this is removed from. So in essence, this is going to be represented as cation present when this is added in excess of your reagent. So you now have to get rid of this and have to go with the two of this. This is what happened in the first portion. In the second portion, you're going to run it also with ammonia. If you run with ammonia, two of the remaining of them, you will be as much as you know that it is lead. But lead and aluminum is behaving alike in this regard. The lead and aluminum is behaving exactly in this regard. But if you react it with ammonia, ammonia solution also going to be releasing us with enough Waec. This is also coming from the NH3. If you run this water, it's going to produce this again. So if you run lead with this, it's going to give you a white precipitate, okay, in drop, but the precipitate is insoluble in excess ammonia, being that lead and aluminum are not going to form complexes with anything like ammonia, being that they are not the block elements. So then we're going to have that kind of interstitial states to allow that formation of that white complexes with ammonia. So they will be insoluble. Okay, but the precipitate will just persist, cannot dissolve. At that same state, you must also happen to be suspecting the two of them. So they will be going head to head at this point. At this point, it's going to be confused. We don't doesn't mean that two cations will be present. That is how there is now third portion. Third portion will now actually prove that it is not aluminum or lead. But how are you going to know all of it? At this point, there will be two tests that we carry out to find out that it's lead that is confirmed. It's either that the third portion will not act to add to this lead in that single portion plus HCl. Of course, you know what is going to come out here. A precipitate of lead to chloride is going to come out here immediately. Precipitate of lead to chloride, because all chloride salts are soluble in what examples of lead. But if it is aluminum, two of these ions is still going head to head. If it's aluminum, what you have is aluminum chloride. Aluminum chloride is part of chloride that is still soluble. So if the ion is an aluminum that is present, no precipitate is formed. You just can't see white precipitate form. So on forming white precipitate, it does mean that it is lead. They must warm it to be very sure. On warming, the precipitate, the white precipitate form. The white precipitate form soluble, dissolve. The white precipitate form becomes soluble on warming, but on cooling, it reappears as needle shape. This actually confirms to us that this particular cation is practical. It's not saying salt to carry out this practical interesting. That is how it's from able to find out all of this that are playing out here. So, but in that case, maybe suppose that they didn't give us to confirm this lead with this. Maybe we can confirm it with maybe something like K2CrO4. Okay, this with lead. Okay, this with lead. This with lead. okay, will give us a precipitate or PbCr04 whose color is what? Yellow precipitate. So is either that you are using this to confirm lead or you are using ISIFE to confirm lead. So any of these two will be there. So what I will do in this video is to now show you the procedure that should be taken, the exact word that should be used, how to write down the correct ions so as to score. If you cannot report this experiment just the way I did it, I just want to explain every of the chemistry of the reaction now to the table. How all of this will be represented in the table under the heading test, observation, and inference. Okay, so you interpret it from the question paper. You see, put all of C. The state you will see initially was in solid states. C plus 10 cm cube of distilled H2O plus shake plus filter. And this is coming up this way. But because of what I told you about what's going to happen, even though that this is soluble salt, but on double composition, lead carbonate will be precipitated from the mixture. So that means C here partly dissolves, gives, and this of filtration, you don't write it on the line of filtrates. So here gives colorless filtrate and white residue. Okay, so that is what we have. Make sure that whatever thing you're writing under observation is in line. This should be in line with this. Just like this is in line with this. So what I have as inference, as my inference, you now say C now in solution, C solution, so C aqueous contains water, soluble, and because of partly solution, water, insoluble, salts. Okay, because that is what it is. You cannot say C is a mixture of soluble and insoluble, C is a mixture of soluble and soluble. So, but C solution contains water soluble. The water soluble part of C is lead to carbonate. The water insoluble is this part. So we're not talking about this again. This is what is going on addition of water, it turns this. So that's why I keep it that way. Okay, so we have this. So we're done with this part of it. Okay, since we have filtered, next question on B will be, or maybe this should be AI this time, will be to the filtrates. Okay, so let's work with the filtrate first while we allow the residue to drain out. So this will be part of it. Let's say this one will be part of the residue. So let's go with AI here. So that means now, okay, that means now that on this note, I'll now say filtrates now. Filtrates from A above plus freshly prepared freshly prepared FeSO4 plus H2SO4. So immediately this is added, you're going to see this immediately. See brown ring formation as the junction of filtrates and ions filtrates at the junction of filtrates. Okay, at the junction of filtrates and freshly prepared ions sulfates. Okay, these are the points you now have to write the inference. The inference should be that okay, the brown gas is NO2. Okay, under the NO2 minus is present. Okay, that is for the test. Okay, the next test will be on the residue. So residue will change to the new equation. So on the residue AI, we have the residue. The first question that will be on residue will be plus dilute HNO3. Okay, HNO3. So maybe add it there, maybe you can have that residue dissolves. Issue dissolve, comma, effervescence occurs, issue colors, comma, odorless gas, turns wet blue, litmus paper red. So make sure the nature of the gas, it is acidic gas. Okay, also the turns lime water. Yeah, okay. To always listen this way. So at this point, I have here that gas is CO2, CO3 2 minus or HCO3 minus. At this point is present. Okay, that is it. Okay, recall at this point, this is the point where the solution here, you got it after the gas is evolved, is what you divide. So you now start to divide. Maybe this is going to be I, or just B. So BII part of it will be first portion from B. First portion from B plus NaOH. So let's start with in drops and over here in excess. Okay, what happened in drop? In drop there is white. Make sure it's in alignment. White chalky precipitate. White chalky precipitate or white precipitate. Okay, so that is to indicate that what should be here. C into plus B, the first thing that will be in your mind, comma, PB to plus, or you even add an element to it. So, at this point, keep it at present. Okay, in excess, the line is in excess, you're going to write that Okay, you're gonna write that since two of the ions here are amphoteric, so you can have that precipitate, the precipitate, okay, precipitate, soluble in excess. You just remove this one, so it's lead or aluminum present goes into the center. So we have it this way. Okay. So for the next okay, so actually it's going to be I. So okay, so this one is going to be second portion this time. Second portion plus, okay, from where it's coming from B above plus NH3 in drops, then in excess. So okay, what are you gonna have here? Also see whites. At this point, I deal with that chalk. Whites precipitate. White precipitates. So here it precipitates insoluble in excess. So under what this is called, we will have PB2 plus or A plus present. So here is saying PB2 plus or A plus present. Now this at the point where we confirm it is with ACL. So let's confirm it on this box. Okay, so to round it out, we have the III. So that means for our third portion plus dilute ACL. Since it is direct of our development, so you have white precipitate. Okay, plus actually even more forgetting that. White precipitates soluble on long, but reappears on cold. Confirmed. So it's a point, alright, PB confirmed against or rather, since there is provision for probate solution, so that could also play away, or third portion plus K2CR before solution. Okay, so with that, you're going to have yellow precipitates confirmed that led to is confirmed. So this is how the practical aspect of this part should be reported. Okay, like I said, at this juncture, you cannot summarize what you do think that is a sum. That is, if you like to summarize, you don't actually know what happened. But since you confirmed lead, okay, you confirmed what else you confirmed? You confirmed lead, you confirmed carbonate salt. Okay, so the two things you'll be able to confirm, you confirm a nitrate salt. So basically, that's look like the two inorganic salts would be lead, carbonate, and another metallic is the VG notes, metallic, lead carbonate and metallic nitrates, or lead nitrates and carbonate salts. Which of these can, supposing you are asked at what you have your inference, please make sure that these ions are correct to score. Nobody's going to score you writing CO2 like this. So like cobalt, they are not the cobalt. So it means that you must maintain consistency. Okay, you must maintain consistency, just like you see maintain consistency in this case. You want to write iron, so it is supposed to be Fe, and 2 plus. Anything like this is wrong. So this is a wrong aspect of iron because it's a small letter. Okay, you see how my ions appears to be in alignment. Okay, please pause the video, go through this sort analysis once again, and then make sure you go through it, use it as your preparation guide, and you see that it's going to be a very useful material for you. Okay, I think at this point we have to stop this video at this point. So try to share our video. If you are new on the channel, please remember to hit the subscription button so that the video like that this can also be sent to your notification. Thank you very much for